Hi, this is Tony Roth, Chief Investment Officer of Wilmington Trust, and you're listening to Capital Considerations. Summer is upon us, and since oceans cover more than 70% of our planet, many of us are likely enjoying any number of water-related activities, such as boating, fishing, or like me, simply laying on a beach. Beyond summer fun, oceans play a significant role in our lives and the global economy. They drive weather, help regulate temperature, and serve as a vital source of sustenance, transport, and commerce. They even present one of the greatest potential hopes for combating climate change, which is using the ocean as a carbon sink to pull carbon out of the atmosphere and into the oceans. To help you better understand the role oceans play in a blue economy, we are revisiting our recent two-part series with Dr. Peter Menocal, Director of the Woods Hole Oceanographic Institution. Peter and I discussed the exploitation, preservation, and regeneration of this important ecosystem, as well as how innovative technologies to increase the ocean's ability to absorb and store CO2 may take us one step closer to solving our climate crisis. I hope you enjoy this important topic. Look for new episodes of Capital Considerations in the coming weeks. This is Tony Roth, Chief Investment Officer of Wilmington Trust, and you are listening to Capital Considerations. Today I'm joined by a very important guest, Dr. Peter Menocal. Peter is the President and Director of the Woods Hole Oceanographic Institution, sometimes referred to as WHOI for its acronym. WHOI is the largest independent oceanographic research institution in the U.S., also in the world. Peter is a marine geologist and paleoceanographer, and he studies deep sea sediments for clues of past climate change. Peter was a professor and dean of science at Columbia University's Faculty of Arts and Science, and he was the founding director of Columbia's Center for Climate and Life, which is an institution dedicated to the study of how climate impacts essential aspects of human life. Peter has published over 150 scientific papers that spanned his decades-long career. We're so excited to have you here today, Peter, to talk about what you study at the Woods Hole Oceanographic Institution. So thank you for being here.
Thank you for having me, Tony.
What we're going to talk about today, and it will be the first of a two-part set of episodes, is we're going to talk about the oceans generally, the health of the oceans, how the oceans are both impacted by climate change, and how the oceans in turn themselves impact climate change. And then the second episode will focus specifically on what the oceans may be able to provide potentially as a partial solution to the climate change phenomenon that we need to increasingly battle against as a race in order to preserve our civilization and our planet as we know it today. As with every episode, I want to remind everybody that Wilmington Trust is politically neutral, and we take no side one way or the other on any of the issues that we are discussing from a political standpoint. So with that, let's get started. This is really a treat for all of us, even though the subject is going to touch on a lot of things that are sort of scary and maybe even depressing. But probably just the place to start is just around the idea that given that we interact with a tiny fraction of 1% of the ocean, which is that very superficial going to the beach, seeing just the very edge of the top of the ocean, why is the overall ocean just so important to us as a people, to the creatures on the planet, to the planet itself?
The answer to that question, why is the ocean important, can be best answered by anyone who's seen that enigmatic photograph of Earth from the surface of the moon that was taken now almost 50 years ago. That showed that we are indeed a blue planet. We're not a brown planet. We are an ocean planet. And as an ocean planet, everything that we care about comes from the ocean. Every other breath of oxygen that we breathe comes from biologic activity in the ocean. Every drop of rainfall is the climate flywheel for the planet. So when we look at how the climate is changing, what we're really talking about is an ocean that's changing. 93% of the excess warming that's come from global warming has actually gone into warming the oceans. It doesn't come as much of a surprise, but it's really something to level set our appreciation for just how profoundly the ocean impacts not only our life on the planet, but also the very sustainability of the planet as we use it.
That means that when we think about our daily life becoming warmer because our atmosphere is warmer, because we don't get any snow any longer. For example, where I live in Pennsylvania, because when it precipitates in the wintertime, the air is not cold enough. So only 7% of that trapped energy is going into that air, and the other 93% actually finds its way into the ocean. Everyone talks about the 1.5 or 2 degrees Celsius that we need to prevent the ocean from warming more than, or we'll reach, I don't know if the word catastrophic is too strong, but something like that. Do I have it right?
We owe a huge debt of gratitude and thanks to the ocean for really mitigating the full impacts of global warming. But I just want to step back for a moment and just appreciate the fact that we do live on this blue marble, and the ocean sustains us for our fisheries. It sustains us in terms of climate regulation. And even if you're a farmer in Nebraska, you thank the ocean. Changes in ocean temperature and salinity are the number one reason that there are year-to-year variations in rainfall and crop yields, not only in the United States, but also in Europe and around the world. So it's this vagaries of the ocean changes that really lead much of the climate extremes that we experience as weather or extreme events like hurricanes and tornadoes and the like. And so it's really this dependence on the ocean and how it changes both naturally and due to human activities that is one of the main reasons why we come to study the ocean.
Where are we today in terms of the health of the ocean, whether you look at it through the lens of how much have we warmed relative to where that critical point is that we can't go beyond, or to what degree have we depleted our fisheries, or is it the degree to which plastics are now infiltrating the ocean? Whatever measures you think are the right ones, what is the current state of our oceans?
When I was actually in graduate school about 30 years ago, we learned that the oceans were probably too big to fail and too massive to really affect over our lifetimes, that we wouldn't see large changes in the oceans. And that turned out to be not correct. The oceans are not only too big to fail, but they're too important to ignore. And so the ways in which the ocean has changed, we talked about the ocean warming. The overall planet has warmed up about 1.2 degrees over the last century or so, and about half of the temperature change is expressed in the ocean. Something like zero point 0.5 or zero point 0.6 degrees centigrade is warming in the ocean, but that warming is distributed throughout, in some cases, kilometers or miles into the ocean. So it's mixed into the full depths of the oceans, and that's really why all the excess heating has gone in there. But the oceans have also changed in other ways. So, for example, as the oceans warm, they can take up less dissolved gases. And so in some cases, for example, off the coast of the United States, both east and west, there are places where deep oxygen levels have gone to zero. This deoxygenation of the ocean. Sometimes people say the ocean is losing its breath. And it's in part due to the fact the oceans are warmer and therefore less oxygen can dissolve in the oceans.
Heard these referred to as dead zones, I think, right?
That's right. Yep, these dead zones. And they're not just off the US, they're all over the place. In some cases, they're expanding and they're impacting fisheries. In some cases, it's due to excess runoff of agricultural fertilizers into the oceans that are stimulating extra productivity in the oceans. But the oceans are, of course, changing most rapidly in the poles of the ocean. So in the Arctic and in the Antarctic, but in particular with the Arctic, the warming there is occurring 3 to 4 times faster than the global average. So it's just rapidly changing. There's about half the amount of sea ice today than when I was born. Same thing for the Antarctic.
Is there any way that you can describe it that we can understand in 30 seconds? What are we doing that's causing that heating to occur so greatly in those extremes?
Yep. And so the reason why it's cold at the poles is because we're a spherical Earth, and at the poles, they receive less sunlight than you do on the equator. And so it's naturally the reason why it's cold there. But the reason why the Arctic is cold in particular, and the Antarctic, is because it's covered with snow or ice. As that snow and ice melt and expose open ocean, you have a bright white reflective surface that's now replaced by something that's dark and absorbing. Basically, it's something called the ice albedo feedback. It's got a complicated name, but a really simple idea, which is you replace something that's white and shiny and reflective with something that's dark and deep and can really absorb a lot of heat.
There are a number of consequences, right? There's rising of the sea level, there's the desalinity due to more fresh water, there's the overall heating of the oceans. How do you get at all of this as an institution? I mean, where do you even start?
We engage with the ocean not only at the coastlines, but we go out onto the global ocean everywhere in the world. And it's only then that you really get an appreciation for the expansiveness of the ocean. I mean, it's just endless. And then, of course, when you dive in the ocean or go in a submarine or do experiments in the ocean, I mean, it's on average 3 miles deep. And so it's a massive space, an inner space of the planet. And so it's really sort of hard to get your head around just how vast it is. And then to realize that it's changing so much, I think that's one of the things that's really sobering. And indeed, it's one of the main reasons that I left Columbia University to join the Woods Hole Oceanographic Institution 2.5 years ago, is that any solutions that we can provide for the planet, this planet in transition, have to begin with working with the oceans to start with.
When I grew up, by the way, I would go out onto the national seashore, all these beaches on Cape Cod that President Kennedy turned into national seashore. And I would go in at 8, 9 in the morning, and I'd stay in there in 56-degree water until 4 o'clock in the afternoon. I would be, as happy as a clam. And now, of course, you can't even go in because there's all the sharks, because the water is warmed, and now there are more seals, and they brought the sharks. So everything's changed. Why do we care from a practical standpoint? And we're very economically focused here. Can you help us understand a little bit better, why is it that the ocean is so important to us when we're not experiencing it really, other than maybe if we have a house on the beach and we're worried about the sea level going up, maybe we'll have to eat more chicken and less fish, or maybe there'll be more rain or less rain in certain areas. But other than that, why does it matter?
When one of our listeners goes to the store and tries to buy cod or tries to buy fish, they'll notice that they're paying an increasingly higher price for it. The fisheries, the ecosystems are moving northward at a rate of about 4 miles a year because of this ocean warming. And basically that means that these fisheries, not only are they being depleted, they're being overfished, but they're also quickly becoming Canadian. They're moving northward rapidly.
Do they get replaced with dead zones, or does something else?
No, they get replaced with the next tier or the next ecosystem that's further south. And so we begin to see southern species like albacore tuna, for example. We see amberjack. We see all different kinds of fish that are coming up that are normally much further south. 90% of the global economy travels on the ocean. 90% of the goods travel over the ocean. So the oceans are this tremendous economy. If the ocean were its own separate economy, it would be the 7th largest economy on the planet. So much of what's changing in the ocean is also changing the fecundity, the productivity of the fisheries and the like. And so as the oceans change, so does our economic relationship with it as well. We also care about it because as the oceans are warming, for every degree centigrade warming that the ocean experiences, the atmosphere can take up another about 7% of moisture into the atmosphere. And so these atmospheric rivers that are now pounding the west coast of the United States, these things are supercharged with rain because they're getting all this water that's evaporating off the Pacific Ocean, which is upwind. And so these are just these atmospheric rivers that are charged with moisture driven from the oceans, piling into the westerlies, coming into the west coast. So that matters, of course, if you're living there, because it affects the availability of water, but more importantly, the sort of emergency floods and droughts that occur. So as the ocean changes, so much of our relationship with the ocean, its provision of water, its provision of food, its climate regulation, its ability to take up carbon, all of these things are in flux. And the one thing that humans don't like is uncertainty. And so as the oceans begin to change, it introduces tremendous uncertainty. Remember that great blue marble, that's what we live on.
If I want to move to California, the only thing that's certain is that I'm going to pay a lot of tax probably, but whether I'm going to be in a flood or a drought condition, which are the two extremes that they seem to always vacillate between, that's uncertain. And it's the ocean that will determine which one I'm in at any given period, it sounds like.
I think that's one of the big takeaways from today is that if we're looking to gain greater certainty about our future, we need to know the ocean that much better.
And you talked about 90% of the world's trade passing over the ocean. And that's, I think, intuitive. Is that what the term blue economy refers to, or is it something broader or different?
The sort of generalizable term of the blue economy refers not only to trade, but also to our extraction of resources from the ocean. So energy, also the fisheries, also now renewable energy. It's really this really larger portfolio of sectors of the economy that intersect or come from the ocean. And increasingly, NOAA, the National Oceanic and Atmospheric Association, envisions this, what we call the new blue economy, which is really the information that's required to make really strategic use of the ocean and make strategic decisions about how the ocean and ocean processes can improve human existence around the world. And this is actually one of the big focus areas here at the Oceanographic.
So when you look at the portfolio, Peter, of the many, many projects that you undertake at WHOI that are funded by grants from the government, et cetera, there's a set of those that are directed at sort of measuring and calibrating, I would imagine, how the oceans are doing. And then there are the projects that you've told me about in past conversations that are really directed at trying to help the oceans, trying to improve our lot with respect to the oceans. Where do you think the most important work is happening?
One way to answer this is just, again, taking that blue marble image. It's just a vast area to monitor and to observe. And so our ability to observe these changes in the ocean is really driven by our ability to lead new technologies, to develop new ways of observing this ocean in transition. It's not just the temperatures and the salinity of the ocean that's changing. It's the fisheries and the productivity and the fundamental functioning of the ocean. Remember, it provides every other breath of oxygen we breathe. If some aspect of the ocean were to change, something fundamental, such as the primary productivity in the ocean, we would notice it immediately. And so one of the main things that we're focusing on is how can we develop technologies to better observe and understand this ocean in transition, and in particular with regard to things that we really care about. So for example, coral reefs. As the oceans are warming, the oceans have heat waves just like we have on the atmosphere. And these heat waves will wash upon these coral islands in the Pacific and in the Atlantic, really everywhere in the tropics. And they cause this bleaching. And this bleaching of coral reefs is, one of the sadder things that's happening right now. Well, we have a team here at WHOI that is focusing on how we can restore these coral reefs so that they're more resilient to these heat waves. Actually, one of the things our scientists are doing is just fascinating. A healthy reef actually gives off a specific underwater sound. It's a lot of clicking and chirping and fish songs. It's basically like a party going on down there. And if you listen to a healthy reef, it's a very noisy cacophony of sounds. In contrast, a dead reef is pretty quiet. And so one of the things our scientists is exploring is actually playing the sounds of a healthy reef in a degraded reef. And it turns out that this acts as a magnet for all the fish and the other coral species to start to establish a new outpost on this degraded reef. And it appears to be working. Much of what we're doing is trying to get at this cutting edge of what are some of the ways in which we can apply novel science or innovative technology to address some of these really rapidly changing problems, such as the changes in the fisheries or changes in coral reefs or understanding how rapidly the ice sheets are melting. These are all things that, if you think about it, there are no eyes on these problems. They're happening in the oceans. We're not living there. We're not able to observe it except for the efforts of these amazing scientists.
There's something that's very, I think, relatable and tangible about the idea of plastics in the ocean. We can all relate to the idea that plastics will find their way into the ocean. I think that historically, we thought about plastic bottles floating around in the ocean, and we all understand that they're sort of there forever. And we've all heard about the big plastic debris field somewhere in the middle of the Pacific Ocean, which is the size of our country or even larger, that's just full of plastic. But then more recently, we've been hearing about this microplastic problem. Can you just talk to us a little bit, Peter, about the whole plastics issue and what can we do to help?
The number one thing is to reduce your utilization of single-use plastics. We like to think of recycling, and I think probably most people make an effort to recycle. I've heard it referred to as wish cycling, and that we don't really know the fate of the material that does get recycled. Most of the plastics that are in the ocean now have actually come from countries other than the United States. Obviously, we do our fair share, but most of it is coming in through point vectors along the developing world, particularly in Southeast Asia and then along the Central American coasts. But these plastics are coming in through these rivers, and then they are injected into the ocean. And because the ocean has these gyral circulations, so there are 7 big gyres on the planet, these gyres, the center of them, have accumulations of plastic, both large macroplastic pieces and also these microplastics that are really microscopic. These are indeed continent-sized accumulations of plastic. They're little islands of plastic. The best way to reduce the flow of those plastics is really threefold. First is collecting the plastic in the rivers before they make their way to the oceans. There's an effort to do that. And then actually collecting plastic in the open ocean. There's an effort that's focusing on that, that's led by a Dutch team. That's a very difficult job, but it's actually they're increasingly successful at it. But the third way, and actually a way that we're leading research here at the Oceanographic, is to develop new marine organic-based plastics that can act as containers that will actually degrade when they're exposed to water and ultraviolet radiation. There are innovations that can happen on the chemistry side that are also promising as well. But the bottom line is use less plastic.
At Hui, there are projects to figure out how can we build a water bottle that instead of lasting for 1,000 years, will last for a year or two and eventually will just disappear, or not eventually, but fairly quickly before it does too much harm?
That's correct. That's sort of the holy grail of the petrochemical industry, is to find those plastics that have these multiple uses that can contain different kinds of liquid that will degrade in the natural environment. That's still some ways away, and just the volume of plastic, as we all know, is just so massive. So again, a lot of it comes down to our personal behavior. There are efforts to collect it at the places where it enters the ocean, and also once it's accumulated in the ocean, there are basically these large nets that are accumulating it, and they've captured thousands upon thousands of tons of the plastic, but there's millions upon millions of tons to collect.
Our second episode is going to focus on the relationship, the critical relationship between the oceans and the atmosphere, and the role that the oceans can play in helping to circumscribe this global warming that's happening, or limit it, or reverse it in some sense. And you talked about the ocean holding 93% of the energy, if you will, that comes down from the sun that gets trapped in the earth, 7% going into the atmosphere. And it would seem like it would be what I think of as a zero-sum situation. In other words, it's going to go either in the atmosphere or it's going to go in the ocean. The ocean's going to heat up and that's going to heat up the atmosphere. It doesn't seem like it would make any difference. So you're going to tell us that that's not the case, I think, and that there's potential ways to take that energy and, if I have it right, somehow turn it into a harmless form of carbon that then sits in the ocean. But take us through what that's about, just enough to get people intrigued for the second episode, which is going to be really about that.
The single most surprising factoid that I think engages people when we talk about it is that you could take the entire carbon dioxide problem that is now in the atmosphere. In other words, the whole thing that we're worried about. And if you could magically take that carbon and mix it into the full depth of the ocean, not just the surface, but the full depth of the ocean would barely notice it. It would represent about 1 to 2% of the carbon reservoir that exists in the ocean. And this is because the ocean is like a gigantic natural carbonated beverage. It's this fluid filled with life. It's 50 times more carbon in the oceans than are in the atmosphere. And so the ocean is this tremendous reservoir for carbon, natural reservoir for carbon. One of the things we're looking at is the ways in which the ocean can intentionally take up carbon and store it at depth in the ocean where it's durably stored for something like a century to a millennium. The oceans are really the only mechanism on the planet that can take up carbon at the gigaton scale, at the billions of ton scale that we're putting it in the atmosphere. And there are technologies that are being explored to do this. Our number one position on this is not so much to be an advocate for what's called marine carbon dioxide removal, or MCDR, but rather to lead the advance in understanding and technology that will inform whether this is a wise or an unwise course of action. What I can say is that this is urgent. We have something like less than a decade to basically choose to do this or not. If we choose to do this, we can mitigate some of the worst impacts of climate change. If we don't do it, we own a future that is increasingly uncertain and increasingly actually physically dangerous for humans and for other ecosystems and plant and animal life on the planet.
So that's a bleak, if you will, but realistic, I think, clarion call to really become informed. And that's what we're going to do on our next episode. So I think for this episode, if there's one takeaway, it is that the oceans present tremendous resource and opportunity, both in terms of what we've experienced as participants on the planet, as citizens of the planet, to provide enjoyment and richness and sustenance, but they also provide potentially an opportunity to help fix this profound problem we've created. So we're going to talk about that next. So stay tuned for our next episode.
Thank you, Tony.
I want to thank our listeners, and I want to remind everybody that you can go to wilmingtontrust.com for a full roundup of all of our latest investment and planning ideas.
This podcast is for educational purposes only and is not intended as an offer or solicitation for the sale of any financial product or service or recommendation or determination that any investment strategy is suitable for a specific investor. Investors should seek financial advice regarding the suitability of any investment strategy based on the investor's objectives, financial situation, and particular needs. The information on Wilmington Trust's capital considerations with Tony Roth has been obtained from sources believed to be reliable, but its accuracy and completeness are not guaranteed. The opinions, estimates, and projections constitute the judgment of Wilmington Trust as of the date of this podcast and are subject to change without notice. The opinions of any guest on the Capital Considerations podcast who are not employed by Wilmington Trust or M&T Bank are their own and do not necessarily represent those of M&T Bank Corporate or any of its affiliates. Wilmington Trust is not authorized to and does not provide legal or tax advice. Our advice and recommendations provided to you is illustrative only and subject to the opinions and advice of your own attorney, tax advisor, or other professional advisor. Diversification does not ensure a profit or guarantee against a loss. There is no assurance that any investment strategy will be successful. Past performance cannot guarantee future results. Investing involves a risk, and you may incur a profit or a loss. Any reference to company names mentioned in the podcast should not be construed as investment advice or investment recommendations of those companies. Third-party trademarks and brands are the property of their respective owners. Third parties referenced herein are independent companies and are not affiliated with M&T Bank or Wilmington Trust. Listing them does not suggest a recommendation or endorsement by Wilmington Trust. Private market investments are only available to investors that meet the U.S. Securities and Exchange Commission's definition of qualified purchaser and accredited investor. Facts and views presented in this report have not been reviewed by and may not reflect information known to professionals in other business areas of Wilmington Trust or M&T Bank, and may provide or seek to provide financial services to entities referred to in this report. M&T Bank and Wilmington Trust have established information barriers between their various business groups. As a result, M&T Bank and Wilmington Trust do not disclose certain client relationships or compensation received from such entities in their reports. Investment products are not insured by the FDIC or any other governmental agency, are not deposits of or other obligations of or guaranteed by Wilmington Trust, M&T Bank, or any other bank or entity, and are subject to risks including a possible loss of the principal amount invested. Wilmington Trust is a registered service mark used in connection with various fiduciary and non-fiduciary services offered by certain subsidiaries of M&T Bank Corporation, including, but not limited to, Manufacturers and Traders Trust Company, M&T Bank, Wilmington Trust Company, WTC, operating in Delaware only, Wilmington Trust N.A., WTNA, Wilmington Trust Investment Advisors, Inc., WTIA. Wilmington Funds Management Corporation, WFMC. Wilmington Trust Asset Management, LLC, WTAM. And Wilmington Trust Investment Management, LLC, WTIM. Such services include trustee, custodial, agency, investment management, and other services. International corporate and institutional services are offered through M&T Bank Corporation's international subsidiaries. Loans, credit cards, retail and business deposits, and other business and personal banking services and products are offered by M&T Bank, member FDIC. Copyright 2023 M&T Bank and its affiliates and subsidiaries. All rights reserved.